one of the more popular programming books that you can buy is Software Craftsmanship. And on the front cover, it has a picture of, I think, like maybe a chisel or maybe even a plane. This in particular is a Stanley Bailey number 4, and I have some others. But this tool requires careful calibration of the dial knobs. You have to keep the blade sharp, and there's just a number of things that you have to make sure that you have set up on this tool. And I think the same is generally true for software engineering. You have to make sure that you have the correct logging systems in place. You have to make sure that you have the correct cloud infrastructure. What does your deployment pipelines look like? What are your code? Honestly, just what do your code bases look like? How are they structured? And how are you getting from your local machine out into production? There's so many things that go into software engineering that honestly I don't think we talk enough about, especially as we're learning the discipline. The same goes for woodworking. There's so many fine details that you have to make sure you get correct when you go to make a piece of furniture. Like, how do you cut a line that is straight? How do you draw or use a marking knife to get a nice edge, and then come in and take a chisel to give you a cutting wall that you can then take a pole saw and then cut a clean line that's straight? It's all these things that kind of you don't think about, but as you kind of go and develop these things down the years down the road, you're going to develop all the skills, but you're not really going to think about those as you're doing them. It's just kind of going to be muscle memory. The same thing I think about when I kind of relate the same kind of skills to software engineering in terms of deployments. A lot of things I think we take for granted once they're set up. How do we replace secrets? How do we replace variables, environment variables when we deploy? How do we handle dev environments compared to staging and production? Those things, once they're set up, we generally don't think about them again unless there's a problem. And the same thing goes with tooling for woodworking. Once we get our tools set up and once we get kind of the muscle memory behind it, sometimes we forget, all the basics that we've had to learn to get to that point of not having to worry about it anymore. And the same goes for software engineering. I think back 6 years ago when I started, I didn't have a clue about deployments. I didn't know how to manage different environments. I didn't know the difference between in .NET app settings and app settings.development. I didn't know how that was handled. I didn't know where to look in a .NET solution to see the difference of those things. And sometimes I feel like it takes me getting back out here to keep me grounded in software engineering, because software engineering can be a very nebulous career path, and it can be very abstract, almost to the point where you kind of lose sense of what's real and what's not. And I think sometimes software engineering can feel very immaterial, and sometimes the things that we make, depending on what your team looks like, you may never even see it come to 100% fruition. And I think that can be very discouraging. And I think that can lead to a feeling of things not being real, because you don't ever see them to completion because of whatever reason. And this is where it's a little different than woodworking. Woodworking, when you build something, you have the physical object or the piece of furniture that you made, and when you put your final coat of finish on and you let it dry, and you take it inside your house and you use it, then it's done. Then you're done. You might have to do some maintenance in terms of adding additional oil, every so often, and maybe keeping it out of the sun so it doesn't rot. But for all intents and purposes, you're pretty much done. You've completed your task of making a chair. And software engineering, sometimes you never complete the task of making the chair. Sometimes you get it to 80%, and then you get sidetracked with all these different problems, and then you're never able to complete the last 80%, and that last 20% is what just completely just drains you mentally, because you never feel like you can get a grasp on the last part, and therefore never see it come to 100% fruition. And I don't know if it'll ever come to 100%, but I think mentally you want it to. You want to feel like you built something that works and something that is done. But I think the concept of done in software engineering doesn't exist. And as I've gotten older in this career, and I'm realizing that done, I really don't think ever exists in software engineering. And I think that it's the ability to cope with the fact that you're always going to be hovering around the 90% mark that really is going to set you apart, I think. But I think it's very important that, as we kind of progress in this career, that we really focus on writing less code when we start advancing in our careers, and really focus on documentation and training and making it easier to maintain the existing system, because that's what's going to matter. If we don't have the documentation in place, if we don't have the test files in place, if we don't have all the requests documented and structured in a way that somebody can come in and read those and make sense of the system. As an example of that is, sometimes you can use, if you use Postman or any of like the open source equivalents, you can make collections of requests, and theoretically you can set it up in a way where somebody can come in and read the collection and run a collection and do kind of a pseudo test of the system by way of execution of requests in the same in the same order as you would if you were actually using the system itself. And setting up what I would consider to be quality of life things is absolutely critical, because we're inevitably going to come to the point where a new team is going to have to take over our work, and if they're struggling to solve all the same problems that we had, then we didn't succeed in our job, because all we did was set up the team to go back and figure out what we already figured out. But if we didn't document it, then they're going to be in the same spot we were. So I think that, as we consider code, sometimes writing no code is really the answer. And I think sometimes deleting code is really the answer, because it's kind of like if we were to take a chair and we were unhappy with the chair, or we needed to make it taller, we could go ahead and add little risers on the bottom, but you would see the line. We could add a chamfer, we could add we could do something to kind of make that line a little more seamless, but it's never going to go away. You're always going to see the line, and it's always going to be there. And the more we try to put a Band-Aid over that line, the worse the chair becomes, because you begin to see all the imperfections. And the same thing in a system. The more we just kind of throw Band-Aids over something that we see, the more we skip out on adding logging or monitoring or cleaning up something that we needed to fix 6 months ago. The more we do that, the worse the problem becomes, and the harder it becomes for the next team to solve. And I think that that's really the crux of the issue, and why software engineering is perceived as being so complicated. It's because of these issues that never truly get solved. And I think carving out the time to solve those is absolutely critical. And I think that as we, get to, developer 2, senior developer, or whatever spot you're really at, I think that just pushing to make that time is essential. And I think that should take precedent over a lot of things. Because I think that value-adding features have to be looked at in two ways. If we add something that, has a perceived value of X number of dollars, we should weigh that against the value of maintaining the system and making it easier to work on. And we track that by how many hours we would estimate somebody coming in to try to diagnose an issue. Because when that issue inevitably comes, it's going to take a while to fix. And if the issue takes a while to fix, maybe a couple weeks because we don't have any logging, then it's going to be a problem. And this is a universal problem everywhere you work, right? There's always tech debt. Tech debt is one of the biggest hot topics anywhere you go. And I think that as we hopefully work together on this, we can try to all kind of be in agreement that there should be kind of there needs to be time to solve the tech debt, and it's going to be a problem anywhere you go, because that's what just inevitably happens in systems. But I think just the ability to track and measure the cost of that tech debt is critical. And if that doesn't already exist, then I think we need to make that on our team, and make it, and make it clear that if we don't do this now, then it's going to come back and we're going to have to fix it. Because we all want to write quality code, and we all want to make quality systems that perform well. But the only way we do that is going to be through careful, deliberate action to tackle the tech debt problems. And that's the hard part. And as we think about it in the context of woodworking, if we don't start with a flat, straight surfaced board, then our end product is not going to be quality, because it's going to be all bowed and cupped in places that you don't want it to be, and all. It's not going to look right. Same with the system. If we're not starting with a good foundation, the end's not going to be quality. And if we get it to a spot where it functions but it's not good, we need to immediately write a story that says, hey, this system works 80%, but to accomplish the last 20%, we have to do ABC, and that needs to be prioritized somewhere, and then also we have to make sure that the whole team is on board for what has to be done, because if it's just you, then you might have a harder time getting that stuff passed. But if you're able to measure the value in terms of dollars for what would happen if you didn't address the tech debt, then it might add hopefully more to your case. But anyway, so I just kind of wanted to draw a parallel, at least for woodworking, to software engineering. So I'll see you in the next one.